A differential equation is an equation that gives us information about the derivative, but doesn't necessarily tell us what the function is. To solve a differential equation, we need to find out what that function is. Now, some differential equations can't be solved, and so the best we can do is get a slope field. But sometimes we have an equation that is called a separable differential equation. And that means that we have the x's and the dx's can be separated from the y's and the dy's. All right? So we have something called a first order separable differential equation. If it's in this form, that looks like this. dy dx equals some function of f times some function of y. Okay, what we're going to do is we're going to separate it and we're going to integrate it and find the value for y, or the equation for y. So as you're doing this, the key is to treat dy and dx as infinitesimal variables, kind of like Newton and Leibniz thought of them as infinitesimals, infinitely small amounts of change. So let's see how this works. So for example, we've got an equation dy dx is equals x squared over y squared. And we want to solve this. We want to figure out what is the equation y that fits this. Okay, so we're going to find a general solution, and then we're going to find some particular solutions. Well, what we're going to do is this. We've got dy dx equals x squared over y squared. And we're going to kind of cross multiply this. Again, just thinking of all these as values. And so if we cross multiply, we get y squared dy equals x squared times dx. Now, we want to get rid of the dy because we want to go backwards and figure out what this is. So what we're going to do is we're going to integrate. Now, by the way, up here, it wouldn't have helped much to integrate right away because this is not a function of x. It's a function of x and y. That's the problem. If it was just x, we'd have no problem. We could just integrate right away and we got it. Well, integrating here, we see that we have y cubed over 3 equals, and we can say plus c there. We'll see what happens with that c. Then we've got x cubed over 3 plus some constant c. Now, sometimes we'll say, this is constant. Let's call it constant 1, constant 2. They are different numbers. All right, in the end, they're just constants. Let's get rid of that 3 maybe by multiplying the whole thing by 3. If we multiply the whole side by 3, we end up with y cubed plus 3c1 equals x cubed plus 3c2. We're trying to solve for c here. Okay, that's our goal. I'm sorry, we're trying to solve for y is our goal. We will solve for c here in a minute, but so if we subtract this 3c1 minus 3c1, we get something like this, y cubed, x cubed, and this is just another constant. Maybe we'll call it c3. A different number. Again, all we really care is that it is a constant. All right, we're now trying to solve for y, so we got to get rid of that cube. So the last thing we're going to do is we're going to cube root this. All right, and we see y equals the cube root of x cubed plus, and I'm going to drop that subscript. It's just c, a constant. In the end, we've got all these different constants. We're going to have a constant. Now, what's important is that it is inside. That's going to be important. It's not always going to end up out here, like we're kind of used to seeing in some of the stuff we've done. All right, so y equals x cubed plus c. The cube root of that, okay? So there's our function. Now, this is a general solution, all right? This is general because it represents a whole bunch of functions, because c could be lots of things. Now, if we have some more information, like we know that y of 0 is 2, that means when x is 0, y is 2. So we want to find the particular solution now for when that is true. So Let's do that. Let's plug in, when we plug in 0 for x, we should get 2 for y. All right, so 2 equals the cube root of 0 cubed plus c. Well, that's just 2 equals cube root of c, and cube both sides, and so 8 is c. So our answer here is y equals the cube root of x squared plus 8. That is the solution that has this slope. It is the solution of this differential equation, and it goes to the point 0.02. All right, so, well, let's try a couple more here, see what we end up with. This might be a good one to pause the video and practice. Let's see what we get. When x is 0, y is -2. So we have 0 cubed plus c. All right, so that's just c. So this is going to be -8 equals c. So y equals the cube root of x squared. Actually, I'm a little goof there. That's x cubed, right? X cubed minus 8. Same idea. And then last one here, what if we get 0, 0? So when x is 0, y is 0. So, well, this one's going to be 0 equals the cube root of 0 cubed plus c. So this one's just going to be 0 equals c. And so we just simply have y equals the cube root of x cubed, or y equals x. So it just becomes a line. And that's how we solve a separable differential equation. Again, the key is that it's separable, and we can end up multiplying or dividing so that we get all the y's and dy's on one side, all the x's and dx's on the other side. All right, let's try one more. This one's going to be a little different because we don't have a fraction over here, but we want to find the general and particular solution for the separable differential equation here. And so we have dy dx equals x squared y. Now again, we want to multiply or divide to get the x's onto one side and the y onto the other. So we've got to multiply both sides by dx to get this dx moved over to here, all right? And let's divide by y. So we have dy divided by y. Or you might want to write this as 1 over y dy if that's a little more appealing to you there. And now that we've got all the x's on one side and all the y's, we're going to integrate. So let's integrate both sides. Use what we know about integration. This is x cubed divided by 3 plus c. And when we integrate 1 over y, we get the natural log of y. Now, we saw in the last one that we just end up with a single plus c. So we can write, plus c on both sides, but if I put plus c here, my next step is to subtract that constant over and just get a different constant over there. So it's an okay practice just to put the plus c on one side. Well, we're almost done. We want to solve this for y. So what we need to do is the opposite of a natural log, and that is make this an exponent, or we call this exponentiate. So we're going to take this to the e power equals this to the e power. And we end up with our particular solution, which is y equals e to the x cubed over 3 plus c power. Now, remember when we add exponents, that's the same as multiplying. So e to the m plus n is the same as e to the m times e to the n. Remember that? Well, we're going to take this one step further. You're going to see this often. We'll have, this is just e to the, I'm going to flip them around, e to the constant, e to some constant, I should say, over times e to the x cubed over 3. Well, e to the constant is just a constant. Not necessarily the same constant, okay, but it is a constant times e to the x cubed over 3. So either answer is acceptable there. You're going to see this a lot. It's a little simpler because you don't have that. All right, and so now we can go find this. This is the general solution, remember? And so to find the particular, we can substitute these things. And if we put 0 in for x here, we have and 1 in for y. So x is 0, y is 1, all right? Let's break this up so we don't have too much going on. Okay, so we have y equals c, I'll copy it down here, c e to the x cubed over 3. Okay. So when x is 0, we get 1 for y. So 1 equals the c that we don't know times e to the 0 cubed over 3, which is obviously just 0. And e to the 0 is 1, so 1 equals c. So in this case, our particular solution is y equals 1 for the c value, but we don't actually need to write that, so we'll just have e to the x cubed over 3. Remember, the solution to a differential equation is a function. So this is the function that goes through this point that meets the criteria for that differential that we had up above. All right, last one here. Let's plug in 0 for x, and we get negative 6 for y. So negative 6 equals some other constant times e to the 0 cubed over 3. Well, that's nice. That's just going to be, again, negative 6 equals c. All right, so that's that starting value. Y equals negative 6 e to the x cubed over 3. There is another particular solution for B. This is part B, and this is question A. So that's how we find particular solutions when we have a product here. We're going to end up dividing, and you're going to get a log in this case. It's going to show up often. All right, so that's the idea. Once again, the big steps are get all the x's on one side, and x's and dx's, the y's and dy's, and then integrate.